Hello and welcome to the first edition of the Canapé podcast. I'm Harry Mack. I'm the project manager for the Creating a New Approach to Peatland Ecosystems project. Today I'm talking to Dan Hoare. Dan, do you want to introduce yourself?
Hello, Harry. Hello, everyone. Yes, my name's Dan Hoare, and I work with the Broads Authority, and my role is Head of Construction, Maintenance and Ecology.
So Canapé stands for Creating a New Approach to Peatland Ecosystems. This project is an Interreg project funded by the North Sea Region Programme, and we link partners across 5 countries looking at better management of peatland or wetlands. We have 8 pilot sites scattered across Belgium, the Netherlands, Germany, and Denmark and the UK, and this podcast series will be doing a bit of an overview of what is being done at each site and talking with each of the site managers. We are starting today with Hickling Broad in the Broads, and we will explore other sites in future episodes. If you want some more information and background on the project, please check out our website, northsearegion.eu/canapé. So on the slide that you can see today, we have a lovely picture of a beautiful kind of sun rising over a glassy water. Dan, do you want to talk us through a little bit what we can see here?
Well, yeah, this is a sort of an iconic shot of the Broads, really, in terms of the view, the landscape, the vista. So the Broads is characterised by large expanses of open water, so the Broads themselves, and these are shallow lakes that dot around the catchment area of the Broads and within the national park. And in surrounding these lakes, then there's extensive reed beds, and you can see that in this image. So all of the machinery you can see, though, at the bottom of the picture there is our technical operational kit that we need to carry out this project for the Canapé project. So we can go into the sort of technical detail through this podcast.
Yeah. And if we move to kind of the next picture, we can present people with kind of an outline of what the objectives of the project here is. So we've got an aerial shot that was taken by drone in June of 2018, showing very much a similar area to the previous picture. And then we have, following on from it, a CG representation of what we're trying to create, which is essentially extending this reed bed out. So Dan, could you explain why we are going ahead and building this extra hectare of reed bed?
Certainly. So within these shallow lakes, over time, some of the forces that act on the vegetation around the edges of the lake have changed. So erosive forces due to wind or waves or just the very structure of the reed beds themselves, forces act stabilize that. So in the past, in the Broads, there's been very high nutrient levels, and this has caused some of the reeds, the sort of vegetation around the edges, to become over vigorous. And there's been various hypotheses about why these reed beds destabilize, but essentially some of the large areas of reed bed around the edges of the Broads have disappeared. So they've eroded away, the reed bed has been lost, and that valuable reed bed habitat that's sort of half in the water and half out, it has disappeared. So looking to restore some of those features and looking to move some of that sediment that has then been eroded away has been where we can then create some win-win projects to both restore the habitat and also then dredge and remove the sediment from where it's gone, where we don't want it to be.
Okay, and what's the benefit of, say, putting it into this type of area rather than spreading it on a neighbour's field, as I know has been done in the past?
Yeah, so there's multiple options. So dredging projects, actually digging the mud out of the lake is invariably the relatively easy bit. Is then what do you do with the material once you've dug it? So around the edges of as you can see in this picture here, you've got extensive reed beds. So there's not a sort of traditional or a nominal bank you can place that material on. There's just no structure there, and you'd be damaging what are protected habitats. So as you mentioned, we've where there's agricultural fields adjacent to some of these sites, we can pump the sediment onto those, and then the sediment is reused for agricultural benefit. There's sort of nutrient value and carbon value and organic matter that can then be added to that arable soil for crop production. But here, there was an opportunity to actually physically rebuild a reed bed through pumping sediment and containing it within the water of the lake, and actually recreating a submerged sort of land-based habitat, which we could then develop the reeds from. So the benefits there are the sediment remains wet. So instead of being onto land where it would dry out and then some of the carbon become oxidized and release carbon dioxide back into the atmosphere, in this example here at Hickling, where we were looking to create a reed bed in the lake, that sediment remains wet. So all of the carbon and some of the methane production, it all gets locked into the sediment and stays wet. You're also then getting an added value of you're generating a habitat that was once lost. So there's multiple wins that can happen.
Yeah, and we're always looking for win-win projects. Looking at our next picture, it might be interesting for our watchers and listeners just to get a sense of where you've been taking the sediment from. So we've got a picture, aerial shot of the Northern Broads. So you've got Hickling Broad on your left, and Horsey Mere away to your right, with a kind of solid green line around it that indicates the boundary of the Broads National Park area. How far have you managed to go in collecting the sediment for this space, and how much sediment have you dredged out of this area?
Within the Upper Thurn as a whole, we've moved over the past 3 or 4 years up to about 20,000 cubic metres of sediment. So the channel through Hickling Broad, so the big open water body you can see on the left, Hickling Broad is the largest open water body in the Broads, and there's a navigable channel that runs sort of east to north west up to the village of Hickling, and so that channel is where all of the boats sort of go up and down to gain access. So dredging that channel to a specific depth, which is 1.5 metres below the water surface, has generated quite a lot of that sediment, but we've also then been able to go further afield. With the Canopé project, we've sort of created this reed bed area, we've contained it within an outer ring of geotextile bags, which themselves are filled with sediment. So we've been able to head down to some of the other water bodies. So sort of if you go to the east, so over to the right, there's another large water body which is Horsey Mere, and we've taken some sediment from there. And equally, there's another water body to the southeast, Hyam Sound. And so all of these are connected by dikes or navigable channels. And so we've been able to do a lot of dredging in this area, making sure there's adequate depth for navigation, and been able to utilise that sediment in the reed bed area in Hickling.
And moving on to our next picture, something I was quite interested to see when I was gathering the pictures for this podcast was that already in the aerial pictures we have, you can see quite clearly there's been a difference to the edge, and you can see here with the zoomed in picture the outline of the area we're creating. Something that's quite fun early on in the project, I was told I had to notify Ordnance Survey that this project was going on so they could adjust the OS maps. So we have literally changed the map of Hickling Broad through this project. Just something, as you can see in this picture on the left, you've got this area behind the new peninsula as it's sticking out. Could you tell us a little bit more, Dan, about the advantage of having that bit of sheltered water and what sort of plants we might see there?
Sure. So yeah, this is a really great shot because you can see directly from above the sort of the outline of the project. So the paler lines you can see on the outline of the peninsula or the reed bed. So that's where the geotextile bags are, and all of that area in the middle is the void that's being filled or has been filled with that 20,000 cubic meters odd of sediment that I talked about being generated from other areas in the Upper Thurn. So behind, so to the left on the sheltered bay behind the reed bed. So this is Cara Bay itself, and we thank our partners, the landowner here, Norfolk Wildlife Trust, they came up with the name because in this bay, so in the sheltered area of water behind, which is just under a hectare in itself, is a fantastic home for one of Britain's rarest plants. So we have stoneworts, which are a group of plants that live entirely submerged, and in Hickling Broad there's a particular type of stonewort, the intermediate stonewort, or Cara intermedia to give it its Latin name. And within this sort of sheltered bay is fantastic habitat really for this very rare stonewort to proliferate. And we've done some work within that bay, so we've sort of deepened some areas and given the best opportunity for that stonewort to be able to flourish in what is going to be a very sort of protected sheltered area. If you imagine the main body of the Broad, it's quite a big area exposed to wind and waves, and sediment gets stirred up. But behind the reed bed we've created, that's going to be a lot calmer, and the plants can thrive there. But one other thing, Harry, that is going to be a benefit in terms of that sheltered area. Some of the local wildfowl love eating water plants. So in terms of the ducks and the geese that visit in the winter, and again, the Broads area, particularly Hickling and Horsey Mere, are very important for overwintering wildfowl. So they visit from sort of Northern Europe and Scandinavia. And what do they like to eat during the winter here in Hickling? But water plants, and some of them then eat the invertebrates that live in the water plant beds. So not only is it an area of habitat just for the plants themselves, but everything else that then feeds off it. The food chain is sort of completed in these areas where you've got good water quality and healthy plant beds.
Thanks for that, Dan. Moving on to our next query and question for you. On the next slide, we have a picture which is a cutaway of the structure itself. Could you just talk us through how this is built and what each of the elements are and how they're working together here?
Sure. So this goes right back to the sort of project development and inception. So this is a nice engineer's drawing of what the construction intended to look like before we built it. So this involved different individuals, both staff within the Broads Authority and contractors we employed to help us with the design, the engineering of this. So you can see sort of all the green plants sticking up. So that's the reed bed once the reeds become established. And if you look sort of closer down into this, the obvious thing is the sort of looks like mesh fence that's across the front of the reed bed, and that's particularly important because, again, we talked about the overwintering wildfowl and the native residents of Hickling in terms of our feathered friends, all the ducks and geese. They love nothing better than eating fresh green reeds. So to allow this area to establish, keeping the geese off during that period of establishment is critical, and hence the goose guard. If you sort of look into the cutaway, you can see underneath the water, you've got the sort of paler pink colour, and that's the sediment that we've added over time. And you can see in there's a sort of big oblong sausage shape that's been sort of squished down. And that is one of the geotextile bags filled with sediment, or that's the depiction of that in profile. So the first task we had when we constructed this area was to lay these big geotextile tubes, which are big empty sausage skins, you could call it, and they were pumped full of sediment, and they formed the outer perimeter of the site.
Thanks, Dan. And why do we need the geotextile tubes around the site? Why can't we just add sediment in a big pile and let nature take its course?
Very good question. The sediment dredged from the Broads is invariably very sloppy and wet, so it has no structural strength. It's not cohesive, so it's every engineer's worst nightmare, really. The traditional ways of dealing with sediment have either been to sort of pump it up away onto dry land or create a hard engineering structure, so sort of steel sheet piling or timber piling, which creates a very man-made hard edge, we call it. So it's something that's not permeable to water and for wildlife. So the the geotextile bags offer a sort of bit of a halfway house, a bit of a softer engineering approach, whereby we can reuse some of the sediment. The geotextile bag then sort of becomes covered over, so it can become vegetated, but it provides a toe whereby that loose sediment that was used to fill it up can't be eroded so readily over time. It's likely that some areas will be eroded a little bit, but we can sort of top those up. And the critical feature is once the project's finished and all the reeds established, it sort of blends far more into the landscape and what the surrounding reed bed and broad edge looks like. So that's the value of this particular engineering approach. It allows a far more natural look to be generated. We can reuse the sediment and not have such a visual intrusion in the land.
Thank you very much, Dan, for that. I think if we go to our last picture, we can get a nice image of what this looked like as a work in progress. So this was a drone shot taken in March 2019, where you can see kind of this was when I believe it was just the outer edge had been formed.
Yep.
You can see also here there's a collection of wooden posts surrounding it. What are they for, Dan?
Okay, yeah. So this was at the end of phase one, really. So this is when the bags had been laid and the bags had been filled with sediment. So you can see they're sort of now proud of the water. The water here is about 1 meter to 1.5 meters deep. So we had to pump quite a lot of sediment into the bags to inflate them and create that solid edge within which the reed bed area is to be created. And you can, just make out the pictures there. The sort of the posts are actually alder trees. So these are timbers that were cut within the Broads, and the posts are probably, say, 15 to 20 centimetres in diameter, and they're driven down into the mud. So the mud at the bottom of the Broad is quite soft. So these were maybe 5 or 6 metre long poles, and there's just now 1 metre sticking up above the water. So these poles held the geotextile bags in place when they were being filled. So they gave the initial shape to the perimeter of the geotextile bags, and once the geotextile bags had filled with sediment, these posts help hold them all in place. And the other value of alder is, as a species, it's a wetland species that grows on sort of naturally around the Broads, and these were all hard in the Broads area. But alder as a wood doesn't rot very well when it's wet, so it's a fantastic construction material in aquatic environments and situations like this. So we were able to use a local product that's very well suited to the job. It's biodegradable, and it provides a very, very solid structure for us now to help get that reed bed established.
Yeah, thanks, Dan. That's been really interesting. I think we'll draw our little show to a close here. If people keep watching, I have tagged onto the end of this podcast a video we shot in 2018 to show the process is carried out. It shows the 2 excavators that were being used. So it shows you through how the excavation was done from the point of extracting the mud from the lake bed to pumping it into the bags. And as a little bit of fun, we thought it'd be entertaining to set it to the music of Swan Lake. So you'll have a nice treat for your ears as well. Thank you for listening/watching.
Thank you.